My name's Ilan, and I'm here we'll talk a little bit for the next 15 minutes or so about some monitoring theory with a presentation we call Monitoring 101. Most of the things that we talk about should be applicable regardless of which monitoring tool you happen to choose. It's more about how to make sense of your data and keep track of it, figure out what's important, and less so about the particular tooling you might choose to implement. So first, just real quickly, background on myself. Again, my name's Ilan. I'm at Datadog. I run our technical community and evangelism teams. Prior to that, I did large-scale web operations for online video streaming services, other web operations, things like that. Companies like Edmunds and Uyala. Big fan of open source. Run conferences like Scale and DevOps Days in the U.S. and Texas Linux Fest, things like that. So I don't imagine any of you all are here from the U.S. It seems like most people are here locally in the U.K. But if you find yourself cold in January here in the U.K., come on out to California for a fun Linux and open source conference called Scale. Datadog, if you haven't had a chance to see us down in the exhibit hall area, we're a monitoring as a service company. You install our lightweight agent on your hosts. We collect metrics from all of your applications, whether it be your Java apps or via JMX or via SDKs that we provide. It might be things like Postgres or Cassandra or Redis or all the other tools that are underneath you. We help you bring that all together to create interesting dashboards. So we take time series data from you, metrics and events. We're pulling in about 1 trillion metrics a day at this point. And help you do intelligent alerting and dashboarding. We're hiring. We have offices here in Paris as well as a number of remote employees here in London. So if you're interested in chatting about development or SRE type roles afterwards, happy to chat with you. So before we get into the monitoring piece, I'd like to talk a little bit about DevOps and what it means and what I mean by it and how this all fits together. So back in 2010 or so, Damon Edwards and John Willis, who are sort of some of the thought leaders and the original sort of coiners of the DevOps terms that we use today, came up with an acronym that they call CAMS, which stands for Culture, Automation, Metrics, and Sharing. And these are sort of the 4 pillars of what I would call an effective DevOps team. So what do we mean by that? Well, culture, right? If we're going to go ahead and build all this, we're all developers. We like to build cool tools, but it turns out that all the tools that we build will really replicate a lot of what our culture and our organization does. And so if you had to fill out 20 forms in triplicate to get a VM or a piece of hardware, doesn't matter that containers are faster to spin up now. You're still going to have some crazy web form to fill out to get approval from some director to get a container, because that's what your organization wants. So we want to make sure that we're all aligned and working together fluidly in the direction that we want to go in. And the important thing to keep in mind here is things like this is a barn raising. I don't know how. This is an Amish barn raising, right? There's not a lot of modern automation here, but they're standing up a fairly large, like a building in a day with a group of folks. And why? Yes, there's a lot of heavy lifting there, but really what's making them successful is the fact that they're working together, both specialists and generalists collaborating towards a goal. Now, once you have your culture in place and you're all well aligned, go ahead and do your automation. Build some Java apps, grab your Chef or your Puppet and your Ansible, put it all together, automate it, accelerate what you're doing. But automation needs to be there to accelerate the direction that you as a team have already set and agreed on and are working together collaboratively on. Now, metrics, that's the sort of the core of why we're here. We're here to talk about monitoring. The key thing to keep in mind there is you can't know where you're going if you don't measure where you are right now or where you've been in the past. So you wouldn't drive down the road with your wipers off or your headlights off in the rain. That's a pretty bad situation to be in. You don't want to do that when you're managing production applications either. Right? You want to be able to collect metrics about everything about yourself, whether that might be how the velocity of your team. In this case, I'm looking at how many alerts we've sent a particular team. Right? If you're getting 10,000 alerts, you're not. You're on calls or getting pager fatigue. You want to measure that as well, not just your applications, but your overall team. I imagine there's lots of folks sort of doing agile style development here. I'm seeing a couple nods. So you're probably doing your sprint plannings and you're looking at your velocity and you're doing your retrospectives. Those are metrics too. They're good things to look at and to measure over time. Because you are going to have incidents, you are going to crash, and you don't want to be this guy. If you don't follow him on Twitter, honest update, it's hilarious, but you don't want to be in a situation where the only action item in your postmortem is, I promise I'll add monitoring next time. Right? You want to be able to have that incident once or maybe not at all. And so it's important to collect all the metrics about your environment and understand how you're performing and how you're doing. So keep in mind that collecting data is cheap when you have it. It's really expensive when you don't. So coming back to an incident after the incident's already occurred and realizing that you didn't have the timing between two services or you weren't able to tell when the service actually went down, you're not going to be able to invent that data later. So collect everything that's reasonable right now. And what's reasonable, that sort of depends on your environment, but if it doesn't slow down your application, you probably want it. Storing that data is cheap. We're in the world of cloud, whether you're storing something in a document store like S3 or some other storage provider. These things cost pennies. It's well worth your time to keep it, even if you only look at it some small percentage of the time. So again, instrument all the things, start collecting things when you're in staging, collect it in your local environment. You're not going to know what normal is when you launch your application if you haven't been collecting this data in your staging and development environments from the start. The last area that we talk about is, in that CAMS acronym, is sharing. It's sort of a loop back on culture, but the idea is, as across our development and operations teams, we should be sharing and talking about the same data. We should see the problems that we're trying to solve as the enemy, not each other. So if a memory leak wakes me up in the middle of the night and I'm on call from the operations team, I'm not annoyed at the developer that might have had the bug in his code that might have resulted in the memory leak. I'm mad at the memory leak. Let's get together, let's fix it, let's use graphs and data to be successful about that. We don't want to be in the same situation that the Mars orbiter team was, back in about a decade ago, right? They lost a $125 million satellite because two teams happened to be using different forms of metrics. So one was using the metric system, one was using the customary system. Turns out when you don't convert between your units, you crash into planets and lose lots of money and many years. So make sure that, think of this as well. Like you're launching this Java app that you've made. It's going to go into production. Make sure that the metrics that are important to you are the same metrics that are important to your operations team and your development teams. So when I say monitor all the things, I mean all of the things. I'm talking about containers, databases, cloud providers, all the way up and down the stack. You want to have all that data together so you can be successful with it as you're and correlate between them as you're making database decisions rather than sort of opinions. So that's a lot of data, of course, and so how are we going to interact with that data? What are some of the different ways in which we'll investigate it and know what to alert on? We talked a little bit earlier about pager fatigue and sort of the challenge that if you're getting 10,000 alerts a day, you're probably not sleeping, actually you probably are sleeping. You're probably just turning off your pager and not paying attention. So how do you know what's important? How do you know how do you know what to alert on and what to graph and what to sort of have over your heads in those dashboards? And so the method we've come up with a method. We call it Monitoring 101. There's a link in the slides afterwards. I'm sure the DevOps folks will post it online, but you can see the longer version on our blog. I'm going to give you the TLDR version that fits in about 8 minutes here. So what we encourage you to do is to break up your to categorize your metrics into categories, into these 3 categories: work metrics, resource metrics, and events. And use these to figure out what to alert on, what to use for investigation, and what to keep around for context. So what do I mean by that? We'll use an analogy of a factory. So let's say rather than a web app, we're building a factory. We make, my name's Ilan. People give me a hard time about Elon Musk spells his name differently, or they give me a hard time about his cars or what have you. So we'll say we're making cars in this factory here. So our work metrics in the case of a factory is we're spitting out these cars, and work metrics would be things like throughput. So how many cars are we putting out on a given day or a given hour or a given second? So in your web app, that's going to be your queries per second, maybe on your Nginx or Apache or Tomcat servers. Successes versus errors are going to be how many of those cars show up without wheels or missing hubcaps or with a cracked windshield that are returned as lemons maybe. Or in your web app, 200s versus 500s versus 404s. These are your success versus error rates. These are the things that your customers care about. They pay you for an API that you provide or a website that you deliver. They want to know when these things are going to be performant, meeting their SLAs. They're going to get frustrated if it takes too long for a page to load or if it doesn't load at all. These are the symptoms. These are the things that you care about. Page on these things. These are the leading indicators that are most interesting to you. Resource metrics. These are all the things that go into making up the widget or the car that we're building in our factory. So it's the wheels and the rubber that go into the tires that go in the car. It's the number of components that you have available. How much space do you have left in your pipeline to generate more of these things in your assembly line? And the reason these are important is because if somebody decides that we need to go make 1 million cars in the next year, I need to know how much slack I have in my pipeline to do that. Similar with your web app. If you're going to release, if you're going to take on a bunch of traffic because you just did an amazing booth at Devox UK, you want to know that you have the resources to make this happen. But in general, you don't care about CPU or memory or disk. I mean, you care about them in that you want enough of them available, but that they're not really what makes or costs you money. They are a component of that. So your CEO will never wake you up in the middle of the night and say the API is returning fine, but please work on that CPU usage. We want to know about the things that are helping us make or lose money. Events are going to be giving you context around all of this. So again, it's your booth at Devox UK, it's your ad during something like the Super Bowl or Eurovision or some other big event, or in the case of your application, it's going to be code deployments or configuration changes. So you want to use these to provide context about why your metrics are changing and where they're going. So again, using an example, I'll use Nginx. Work metrics will be things like requests per second on your APIs. Error rates are going to be things like 400s versus 500s. And the resources are going to be, of course, the disk, memory, CPU that go into that. Now, we talked a little bit about events. I'm a little short on time, so I'm going to keep going. So events are sort of the types of things, it's a little hard to see here, but you might overlay an event on your graph. So here, for example, we're looking at I/O over time, and each one of these sort of orange bars here are a deployment that has occurred. And we can kind of try to see if we can correlate, has I/O changed around when these events happened? Is that a problem? So when do we let a sleeping engineer lie? How do we figure out when we should wake you up in the middle of the night? Because nobody likes to be woken up in the middle of the night. What we encourage you to do is to page on those symptoms on those work metrics that we talked about earlier. These are the things that your customers care about. Keep the resource metrics and the events around for providing context about why that happened and use them in your investigations. Now, I know I just said resource metrics are important. If you're a database and you run out of disk and your writes don't happen anymore, don't tell me that I told you not to page on them and that, hey, Ilan, I missed an incident because you said not to page on resource metrics. Use good judgment, page on those things early. But in general, this is a rule of thumb, again, and every rule has its exceptions. So as you get these pages on these work metrics and investigate with the resource metrics and your events, you're going to sort of recurse on this until you find the root cause. Because maybe your web server alerted about increased 500s, but really it's because it couldn't talk to some database or some other API down the stream. And so as you work through this, every layer of your stack has a work metric and depends on some other layer as a resource. So even if you're you're at the data tier all the way at the bottom of the stack, you're still very important. You still have a work metric. Maybe it's SQL queries that you're returning or not returning. And those are things that you should those are the metrics that you should, eat, live, breathe, and sort of pay attention to at all times and alert on yourself. So what are the types of things that we want to ask for our monitoring systems in order to be able to apply this type of framework to our tooling? One is we want to make sure that we're bringing all the data in from all of our different tools into a single place. Not deploying a bunch of different point solutions, one thing for your Hadoop cluster, for your Cassandra cluster, another thing for your Java app, and then looking at 100 different dashboards, turning your neck around all the time. Find a way to look at all of this together and to correlate it, because it does matter. Avoid cryptic alerts. Make sure that everything that you're sending out to your teams at 3 in the morning is actionable. Don't tell me that CPU is high on some database server I've never heard of. Tell me why it's important. If this is down, how are our customers impacted? Who do I call when I'm stuck? Where are the run books for fixing it? And again, it should be actionable every time. If I'm getting paged about things that don't matter, I'm not going to answer those pages. I'm probably going to start ignoring them, and that's when I miss real incidents later on. So again, why is it important? Why it's actionable? Who do you call? And what to do next? Look for things that are host-centric rather than, that are service-centric rather than host-centric. This is the Ptolemaic model of the solar system. This is how we looked at our world when we thought the sun and everything else around us revolved around the Earth. Bunch of crazy lines. If we flip it around, though, and we look at sort of the modern model of the solar system, pretty easy to think about this. And it's a similar idea about your services and your applications. If you're approaching it from a service-centric model, you're going to have a much better sense of if your customers are happy or not than you are if you approach it from a host-centric model. Try to avoid static configurations for your applications, especially in cloud land. You want your monitoring system to adapt as you spin up and remove new hosts. You don't have to have your team show up and do this type of configuration on their own every time you spin up a new machine. No matter how much you love your Puppet, your Chef, your Ansible, it's not going to move as fast as auto-scaling groups or container orchestrators or other tools that we have today in our ecosystem. Make use of your infrastructure tags. Make sure that you can use those all the way down. So whether it's in your cloud providers, your app servers, your monitoring tools, all the way down, consume all these tags and use them to describe what these metrics are. So on the left side, we've got what the metric is, what the time is, and then where this thing is happening. Sort of out of time, but the idea is to ask better questions about your applications in your environment. Everything that's sort of underlined here is a tag. So what type of instance is it on? What type of application is it? Where is it deployed? And then use it, again, to ask these better questions. You don't care about your CPU usage, but you do care about how frustrated your users are. And with that, hopefully if you adopt some of these approaches, you'll stay out of the doghouse. And I'd love to chat with you about your monitoring and any I don't know if we have time for Q&A or not, but happy to chat. But I believe my time is up.